Hey guys, we're like on video a zillion over these concepts. Um, all right, so I3, here we go. Let's look at I3, all right? So I3 is the same as I times I, all right, which is, or I squared times I. Okay, we learned that I squared is the same as -1, and we learned that I is the same as square root -1. So if we combine these two things, -1 times square root -1, we get negative square root -1. Right, so we're just going to use a little logic, doing what we know what I squared equals and what we know that I equals. All right, let's do I to the fourth. So I to the fourth is I times I times I times I, or I squared times I squared. All right, I squared is the same as -1 times -1. -1 times -1 is +1. And so that's it. Let's do some more. Oh, so we're done with complex numbers. All right, and let's kind of go back a little what we were doing before complex numbers. All right, so square root, no, let's pretend that's an x. All right, remember there's an invisible 2 right there for whatever's in here. It doesn't have to be an x, could be a 16, could be a 27, could be an 81, whatever it is, okay? And that's the same as x to the 1/2, and you pull out groups of 2. Cubed root of x is the same as x to the 1/3, and you pull out groups of 3. The fourth root of x is the same as x to the 1/4, and you pull out groups of 4. We did the fifth root of x, and that's the same as x to the 1/5, and you pull out groups of 5. The nth root of x, you do x to the 1/n. So like if it was 6th root, you do 1/6. If it was 9th root, you do 1/9. I don't know. And you pull out groups to n. All right, so notice like 2, that number right there is on the bottom. 3, that number's on the bottom. 4, that number's on the bottom. Whatever's right here, that number's on the bottom. All right, so this little guy right here, like the squared or the 3 or the 4, this number right here, okay, that's called the index. I'm not going to ask you, aside from right now, like these couple of questions, other than that, I'm not going to ask you, okay? Just because I need you to practice a couple of things before I go into what I'm really going to ask you later. All right, so the third root, no, the cubed root of -125 is the same as 125 to the 1/3. Sorry, I didn't mean to scratch it out. And just like 81 is the same as the fourth root of 81 is the same as 81 to the 1/4. But they want us to find the index, which is this number right here. All right, and so that index is 3. That index is 4. And we'll find the root of each. So 5 times 5 times 5 is 125. And so we have a negative, so it's -5. And then we need to figure out a number 4 times is 81. I'm thinking 2 times 2 is 4, times 2 is 8, times 2 is, that's not big enough. 3 times 3 is 9, times 3 is 27, times 3 is 81. All right, keep in mind this, -125 to the 1/3 is different than -125 to the 1/3. And if you don't believe me, you can type it in your calculator. You also need to keep in mind that when you type it in your calculator, for that 1/3 or the 1/2 or the 1/4, you need to put parentheses around that fraction, like the 1/3. Hang on. Or like if we were doing the 4 through to 16, you need to make sure you put parentheses around it, because otherwise you get incorrect answer. So you need to make sure when you do this guy that you put parentheses around these guys, your exponents. All right, so here I want us to rewrite using our radical symbols. All right, so 1/2, that's the same. Remember, you put the bottom number goes outside on the front. And so we're going to write 121. It says do not simplify, so we're not going to take the square root of 121. Okay, we'll just leave it alone. The bottom number goes out front. So 14 to the third. I just need you to be able to go back and forth from having a fractional exponent to a radical symbol, okay? And so that's all I want you to practice right here. Fractional exponent, radical symbol. And then from here, oh, hang on. Uh-oh, where'd he go? I have another, uh-oh. All right, then we'll go the other way. There was another slide somewhere. Where'd he go? And he's at the end. On accident. Nope, not on the end on accident. All right. Make it up real quick. I don't know. 47. 4. 91. 2. All right, let's do these. So the 4 through to 47, I want you to write using a fraction. So that's the same as 47 to the 1/4. And then negative 91. The cubed root of negative 91 squared, that's the same as negative 91 to the 2/3. Because remember, your bottom exponent is this little index, is that little number in front. Bottom exponent, little number in front, bottom exponent. All right, and then we have a couple more things to talk about, and then you'll know everything almost. Everything you've ever wanted to know. Change. All right, the 0 exponent rule means anything to the 0 is 1. So 565 to the 0 is 1. 2x plus 5 in parentheses to the 0 is 1. Anything to the 0, 1. The identity rule is anything to the 1 is that anything. 565 to the 1, 565. 2x plus 5 in parentheses to the 1, 2x plus 5. All right, the product rule, the quotient rule, the power rule, the negative exponent rule, and the extended power rule. I don't care if you know that these have names, okay? I need to make sure that you understand that they have the same basis. These both have x's, these both have x's, these both have x's, or they're both 10s, they're both 2s, or y's, or 4s, or this is an x and a y, so they're not going to be able to talk. All right, so product rule says add. Quotient rule says subtract. Power rule says multiply. I'm going to explain what I mean in a minute. Negative exponent rule says move me. Extended power rule says distribute. All right, so let's do our examples. Okay, so product rule says add. So 2 plus 5 is 7, so it's going to be 2 to the 7th, whatever that is. 2 up 7, 128. All right, y to the 3rd times y to the 5th, 3 plus 5 is 8, so it'll be y to the 8, because we're going to add the exponents. Quotient rule says subtract, so we're going to subtract the exponents. 6 minus 3 is 3. 10 to the third is 1, 2, 3 is 1,000. I'm going to come back to that problem. Power rule says multiply. So that 2 times that 3 is 6. 2 to the 6th is 64. All right, so we're only multiplying the exponents. These coefficients will multiply into normal, so that'll be 15. And then that's a 6, and there's an invisible 1 there. So we're going to, that's really more like a product rule right here. So 6 and a 1 is a 7. 7. Negative exponent rule means move me. So this guy, I need to move him to the bottom. Okay, and since they're the same bases, we're going to subtract. We're going to do the quotient rule. So it's really 1 over x to the 4th. Because 1 minus 5 is 4, and the 5 is bigger and he's on the bottom. Okay, 3 and 5 is 2, so it's going to be 1 over 4 squared. 4 squared is 16, so that's really 1 over 16. Extended power rule means take this 3 and go to everybody. So that's really 2 to the third, x to the third. 2 to the third is 2 times 2 times 2. So that's 8x to the third. 4 squared is 16x squared. 9 squared is 81y squared. This x squared and y squared, they can't talk. All right, and let's do this guy. That x to the 5th needs to go on the bottom. Y to the 4th can stay on top. This x to the 6th needs to go on the top. That y to the 6th goes on the bottom. And then we're going to subtract the 6 and that 5. The x stays on top. That 4 and 6, there's going to be a y squared on the bottom, because 4 minus 6, that's a 2. And the 6 is on the bottom, and he's bigger. All right, and there you should have watched a video about exponents and exponent rules. I'm just reviewing. All right, let's do a couple problems. So anything to the 0 is 1. So this is really square root of 1, which is just 1. The cubed root of something cubed, these things are inverses, so it's just 89. Just like, I don't know, the 12th root of whatever to the 12th. Those will cancel, and you'll get whatever's inside. All right, then we have this guy. 12 divided by 3 is 4. 9 minus 5 is 4. 8 and 9, so the 9's bigger and we're going to subtract. And then the z's on top, but we still have this guy. So I'm going to do the square root of 4, x to the 4, z, 3, y. Square root of 4 is 2. Square root of x to the 4, we're going to do 4 divided by 2, so it's really x squared. Z3, so 3 divided by 2 is 1. Oops, z. With 1 left over. And then the y, we can't do anything, so he stays. And then, so anything on the outside hangs out together. Anything on the inside hangs out together. And so outside, 2x squared z. On the inside is a y and then a z. I'm putting it in ABC order. So that's our answer. And so that's pretty much as hard as it's going to get. Whew, all right. We did, oh geez, a ton of stuff with radicals. Lots, almost an hour probably of that. So go do your practice work. I'm really sorry it's a long homework. But I will talk to y'all later. Bye.